Okay, here is a quick response to our request to look at question on page 121, and we are given this data, and I've retyped the data here, and then we're asked to find how old someone will be with a z-score of 3. Now, I used data analysis to generate this. Let me just go ahead and do it again real quick. It's messing up my results. I'm gonna do it on another page and I'll come back to this. It's gonna be a lot easier because I did use some references. So let's copy the data here, and then you go to data analysis. We want to perform some basic calculations on this. We're gonna need to find the mean as well as the standard deviation. So input range is gonna be the data that's here. We don't have a heading, so we don't need to check this, and I want to put the output right here, and I'm doing summary statistics. So click on OK, and then this generates mean, standard deviation, and standard error, and things like that. So going back to the pre-worked out sheet, now the z-score of 0 means that the x value is equal to the mean whenever the z is 0. Now z-score is really a scale that is quantified by definition, with 0 being equal to the mean, and then a z-score of 1 is separated by 1 standard deviation from the mean. So it means that this 9.484 is the standard deviation, so a z-score of 1 will be that much from it. So 41.68 is going to be a z-score of 1, and then this z-score of 2 would be, so far what I've worked out here is a separation, so this is just the z value times the standard deviation, and that is explained in the textbook in terms of how to calculate the z value. If you look at page 105, you will see that formula there. So this is our response that we're looking for. This is a z-score. The actual size of the separation is going to be 3 times the standard deviation, which is what is here. And then if you add that to your mean, then we get the 61.36, which is how the text came up with that. Alright, if you have any further questions, feel free to reach out to me. But just to summarize, z-score is really a standard, and what it does, it defines the mean as 0 and a z-score of 1 as being equal to 1 standard deviation away from the mean. And we could do z-scores that are -1, -2, -3, and so on. And what these would be, these would just be the z-score times the standard deviation. So this would be the separation, and to get the actual value, it would be the same, the mean, and we are adding the difference, and we can copy that formula. So what this is saying, on a z-score scale, a z-score of -3 is 2.3, -2 is 12.1, -1 is 21, 0 is 31.84. By definition, that's the mean, right? You can see these here. And then by definition, a z-score of 1 corresponds to a value that is 1 standard deviation away from the mean. So that's how we got 41.68. This is 1 standard deviation greater than the mean. That's 9.84 plus the mean to give you a z-score of 1, or the x value equivalent to a z-score of 1. Alright, I'm hoping that this helps. So if it doesn't, reach out to me and I'll be more than willing to clarify further.